Welcome to the INGSA Horizon Series. My name is Nemer, and I'm the Chief Science Advisor to the Prime Minister of Canada. It's an absolute pleasure to be accompanied today by Sir Patrick Vallance, the UK Government Chief Scientific Advisor and National Technology Advisor. I remember our first meeting 5 years ago at Canada House in London. Patrick had been nominated but had not yet started in his role. I too was relatively new in my position. Now, here we are several years later, both of us the wiser for having lived and worked through so many challenges, including the worst pandemic the world had seen in a century. It's amazing how time flies. Previously, Patrick worked at GlaxoSmithKline, where he was Global President of R&D from 2012 until 2017. During this period, many new medicines were approved for use worldwide for diseases ranging from HIV to cancer and asthma. Prior to joining GSK, Patrick was Professor of Medicine and led the Division of Medicine at UCL. His personal research was in the area of diseases of blood vessels and endothelial biology. Since 2018, Patrick has served as a Chief Scientific Advisor to the Government of the United Kingdom. As his tenure will soon be coming to a close, I'd like to take this opportunity to get his views and reflections on his role, the importance of science advice in government, and creating vital communication lines between scientists and decision makers. Welcome, Patrick. So to start things off, maybe we can talk about your experience as the Chief Scientific Advisor over the past 5 years. And perhaps you'd like to speak to us of the importance of science advice systems and mechanisms at different levels of government.
Yeah, thanks, Mona. A great pleasure to be here. And the importance of science advice mechanisms in government were really brought home to me before I started this job, when I decided I would take the advice from a previous cabinet secretary, so the most senior civil servant in the UK. And what he said to me was, science in government in the UK is good in parts, it comes to the fore at certain times, but it isn't embedded in departments, it isn't lived and breathed every day. And he said, if you look at economics, it's embedded. And he said, you need to try and get science as embedded in government. And I took that as a very good mission to try and make that happen. And if you think about it, I can't think of a single policy area, operational area of government where science, technology, or engineering wouldn't make a difference, wouldn't improve the ability to make a good decision. And so that's true whether you think about how we seek our healthcare, how we communicate with each other, about transport, about town planning, about our defense and security. And of course, it's highly relevant to the economy and the growth that one gets from science and technology companies. So every single area of science, of government policy and operations can do with science and technology input and advice. And that's really the mechanism that we've been pushing here, is to say there needs to be a chief scientific advisor in every department. That individual needs a structure around them. There needs to be a budget to accompany that. There needs to be a set of areas of research interest that say what the department doesn't know about, so that they can get academia and other places to work for it. And that structural system across government, I think, is crucially important to embed science into departments, and needs to be coupled with activities to get existing civil servants more able to use science and to get more scientists into the civil service.
I couldn't agree more. As you know, I'm a fan of this system. I've tried to implement it here in Canada as well, and we're making progress. The amazing thing is, once the high-ranking civil servants start working with science advisors and scientists, I think they realize what they've missed on for all these previous years. But and you mentioned this.
It's an interesting point, Mona, because I think very often people don't know what they're missing till they see it. And it is, in a sense, a form of diversity. It's a form of diversity of thinking and backgrounds of this. And I was really struck by one senior civil servant soon after I joined, who told me a story that she'd had allocated to her team a science and engineering fast streamer. And she thought, what on earth am I going to do with this person? Because I don't do science and engineering. But after a few weeks, what she realized was that they were bringing a different perspective to every discussion and bringing a different approach to it and bringing the scientific method into play. And she thought, wow, that has completely changed how my team is thinking and operating.
Yeah, and I think, you know, like you mentioned, everyone without knowing are consumers of science in many ways. So, of course, to get the best science advice, you need great science and knowledge systems from different fields. Now, there are scientists in government, as you mentioned, scientists from academia and the private sector that we would like to see interact more closely or fluidly with folks in government, both on the science and the policy side. But you're in a unique position because you've worked in these three different sectors where there are scientists and in many ways consumers of science. So I wonder if, you know, how would you say these compare in terms of the science, the commonalities, the distinctions between them?
Well, so there's some obvious similarities, which is they're all big organizations, big institutions, and they have similar characteristics in some ways. And scientists are scientists, and they want to talk to each other about science, and they want to spread the word about science, and they want to collaborate with each other. So those are similarities. There were some striking differences I noticed when I moved from academia into industry. When I was head of department at UCL, if I said something was a good idea, it would almost certainly be a signal for most professors to think of why it wasn't a good idea and it shouldn't be done. And I realized after a few weeks at GSK that if I casually said to somebody in the corridor that I thought something was a good idea, there'd be a work stream set up to work out how to implement it. So I had to modulate my language a bit as I made that transition. And of course, in government, there's an added layer of complexity. I mean, it is just phenomenally difficult and complex because of the multiple departments, the competing interests, the structures that take place. But one of the things that we found is that the natural tendency of scientists to want to work together and to want to provide information to each other so that they're informed means that our network of chief scientific advisors across government is one of the great glues across government now. It's one of the ways people know what's going in other parts of government and is seen as such. So I think playing to that natural desire of scientists to collaborate is a really strong thing to do.
Yeah, and to your point, the pandemic, of course, we've seen the success of bringing these three sectors together, the academia, government, and industry, basically focused on a major challenge. You know, we could have said these were high risk, high reward approaches. And I know that in the UK, in Canada, in the US, where governments have sort of realized that perhaps we need to marshal all these forces towards a major challenge or objective. So I wonder, you know, what your thoughts are on how best to support this collaborative, focused approach on a major challenge without taking away from all the other science support systems that we still need.
Yeah, I'll give you a couple of examples. I mean, during the pandemic, one of the things that I was concerned about early on was how vaccines would come and actually be produced and brought forward and utilized. And it seemed to me that existing government structures weren't designed to work with innovation in quite that way. And because of my background, and because of a key point in industry, which is people are always looking for single point accountability and expert teams, which is not always the feature of how governments work or indeed other places, I was very keen to try and set up something that brought in experts, brought in people with manufacturing, R&D, real knowledge, and created a structure with single point accountability to try and drive that towards a very clear mission, which was, can we get vaccines for the population by the end of the year? At a stage when, as you know, we didn't even know it was possible to make a vaccine. And that structure and that ability to bring people together was galvanizing and important because it provided a clarity for what became the vaccines task force to drive that through in the UK. And I think that model is actually quite an interesting one to think about operationally in government. And then the second point to your question is about high risk, high reward research. And as you may know, we've recently set up a new funding agency in the UK, the Advanced Research and Invention Agency, ARIA. My only claim to fame on that is I did actually invent the name for it, which I'm pleased with because it sounds soaring and wonderful, and you want to be near it.
That makes you the godfather.
I don't know what it makes me anyway. But that was set up to try to do a type of research, a bit like DARPA and ARPA agencies in the US, a type of research funding that brings together people to try and tackle integrated missions, difficult, tough problems that are likely to fail, like any innovation. But if they succeeded, they would be really, really important. And that's just launched formally in the UK. Very excited by the CEO and the structure of the agency. And it's not to replace other forms of science funding or to replace other things that go on in government. It's a different way of doing it. And so I think it's a way of experimenting with science funding models to see whether you get the different outcome. And critical to ARIA is it is arm's length from government, really arm's length. I mean, it is set up in statute not to be easy for politicians and civil servants and others to interfere with its progress. And you've got to do that and give it 10 years to run and see whether it delivers its mission. And I think this is an exciting new development, another addition to the landscape.
Yeah, and of course it's a model that we can imagine could be replicated to address some of the issues of renewable energies, of reversing biodiversity, the entire climate agenda. But I want to go back to another very important feature of our workings, and especially during the pandemic, which is the international cooperation and collaboration, of course, among scientists that was happening, but also amongst the science advisors. So I wonder whether you have, you'd like to share any thoughts on this, any things that of particular significance.
Well, what was really interesting in terms of the interaction between science advisors over COVID was it was both the formal and the informal that mattered. So you'll remember, Mona, we had lots of conversations. I can almost picture where I was sitting, sort of just chatting to you and downloading and hearing from you what was going on. And those moments were incredibly important because we were all facing a similar sort of challenge. We all had varying different political responses going on in our country to it. But to know that the sort of science advice system was largely giving the same messages into the political system, and knowing that we all had our challenges with operational delivery against the science advice and other matters was, I think, incredibly important. And I don't know what you felt, but I certainly really valued our chances to chat. And
yeah, very, very much so, very much so. Sorry to interrupt, but I do remember where I was, sitting on many of those, one-on-one calls. And thank you for making the time on weekends and evenings, but also our, collective ones, which for me were at 6 o'clock in the morning, but with 30 people from around the world. And I think that we learned so much faster in real time what was going on, rather than go through the usual channels that would have taken a lot longer at a time when you're really managing a crisis.
And we set up a similar thing in addition to the big sort of 30 plus country ones that you and I were on. A smaller group of 8 or so countries in Europe. We just set up a call to say, let's just speak to each other. Mm-hmm. And it was quite interesting because the first time we suggested it, the people said, I'm too busy, I've got too many things to do. But it became the must-attend meeting for everybody because we had no real agendas. We just talked about what was going on. We learned a lot from each other. It was no officials there sort of trying to sort of manage what could or couldn't be said. So we were very open with each other. And that became powerful. And as a European group, we then last year decided, as things started to improve in the pandemic, we would all meet each other face to face. And we had a meeting in Paris and had great fun to actually, for the first time, see each other and work out who was actually 4 foot tall and who was 7 foot tall, and we hadn't spotted on Zoom.
Yeah, and in so doing, I'm convinced that we have each served very well our country, and served also the collective global good in so doing. So that I don't know if you have in mind some key opportunities that you see for international cooperation in the future.
Well, I think where the science advice system across the world has really been important over the past few years, in addition to what happened in the COVID pandemic, was around events like the G7, the G20, COP26, Biodiversity COP, where the ability to pull groups of people together from around the world easily, who can speak openly and can actually come up with consensus statements or views that can feed into a political or negotiating position, has been really influential. And so we can see it around G7, G20, around pandemic preparedness, everything from the 100-day mission for vaccines, therapeutics, and diagnostics, through to surveillance mechanisms and hubs for pandemic preparedness, through to the work at COP26, when you and many others were so influential in bringing together ideas as to what should be on the agenda for COP26 and how we could put this science advice into a political context for people to be able to make decisions about, and the work that you did recently for the biodiversity COP, where I think the ability to again bring science advisors together, come up with some consensus positions, is influential. People listen to it, and we should recognize that power that brings, not the power to make a decision or to be the policymaker, but the power to make sure that policymakers have the evidence to be able to do so eyes open.
I completely agree, and I have to give you all the credit because you started the trend with COP26, and we saw that it was very effective. And when you think about it, we've talked very often about the fact that whether it's the climate or the biodiversity, there are of course groups of scientists that are working and providing scientific data to guide a policy, and then we have these major conferences taking place with negotiations and so on. But it seemed that there was a gap to be filled in between, so that the scientists are not meeting by themselves and then there is like a valley, and then the rest is picked up, which they pick up whatever they want. So I think that this is telling us that the science advisors have actually a role to play in making sure that the dialogue between the scientists and the policy and the political front basically is maintained, that we don't forget what the scientists have said when we're negotiating the targets and whether they're reasonable, and of course making also sure that we are making the progress that we think we're making, because people forget that science is not only important to tell us what the problem is, or what the solutions can be, but also to monitor progress. And I think this is something that we're starting, to hammer. And it's really thanks to your work with COP26 that we collectively started taking on this role. And I hope that, we continue it for the years to come.
I mean, it seems to me that one of the things is that scientists who haven't been in sort of these sorts of advisory roles sometimes don't know how to pitch their science to policymakers. And I certainly would have been in that state before I did this job. And I've now come to the decision there are sort of 4 key things that science advisors need to think about. First is the evidence base adequate? And if not, what are you going to do about it? The second is, has the science advice that you're giving been understood? And that may sound obvious, but I think it's quite often the case that people will say something, say, I've said it, and that's enough. Whereas actually checking, really being sure that the advice has been properly understood by the people who need to hear it is important. The third is that has the science advice been framed in a way that's relevant to policy? And I don't know about you, Mona, but I've learned a lot about policy and how difficult it is to generate and develop good policy. And it's not the sort of view from a sort of casual chat in the pub, why doesn't government do X, Y, or Z? I mean, it's really difficult to get policy right. And therefore, making sure the science is framed relevant to policy decision makers. And then the fourth point is the one you've raised, which is how can science be used to monitor the progress against the aim? And I think that evaluation point is really important.
Yeah, and when you talk about policy, indeed, it's I certainly underestimated it, and I think that even our esteemed colleagues, political scientists in academia, also underestimated, because it's not only about writing a law or proposing an initiative, but how implementable is it, and et cetera, because very often also policies are developed, but then things bog down in implementation. And I think that there is a lot of science and implementation science, as a matter of fact, that can go into this. So there will be no shortage of science advice, I think, for years to come. And yeah, let's hope that that our colleagues, from the I would like to call it maybe the momentum that was generated during the pandemic in terms of this more frequent exchange between people in government and outside government, that that we can continue on this and be the most helpful possible. Look, there are a lot of things that you and I'm sure wished we knew before we took the job, but I'd like to hear you about what is it that you wished you knew before you took the job?
Well, what do I wish I knew? I wish I knew there was going to be a pandemic right in the middle of my tenure that was going to occupy 2.5 years of the things I was planning to do. But beyond that, what do I wish? I realize in retrospect how little I understood about how government works. I just didn't understand the processes well enough. And it's interesting because I was reflecting that when I moved from academia to industry, I sort of thought I knew how people made drugs and how drug companies worked, and I didn't. I had to learn it when I was inside. And I had exactly the same experience coming into government. I didn't really know. I sort of superficially thought I knew how things worked. And there are all sorts of processes and arcane procedures that if you don't understand them, it can limit your ability to actually be effective. So I guess I wish I'd known that before I started. But having said that, I'm not sure you can really know it before you start, because it's something you have to live and breathe in order to really understand it. But in the UK system, something that I learned quite early on that would have been useful for somebody to have told me beforehand is there is a layer of senior civil servants at a particular layer, one below the permanent secretary, who are crucial for getting things done across government. They are the key people to interact with in terms of getting stuff done in our system anyway.
And I completely agree with you. I think the pandemic has been an accelerated course in understanding how government works, because I don't think that 5 years is long enough to really understand how government works, but it's certainly a great start. So, Patrick, thank you so much for this wonderful discussion today. And I mean, how lucky we have all been these past 5 years to have been able to share in your wealth of expertise in health, in drug manufacturing, in bringing these different folks together. I certainly have benefited greatly from our interactions, and I hope you realize that your work has made an enormous difference, not only in the UK, but really well beyond. I have shamelessly copied everything that you have done, and no one has blamed me yet for it. So I'll look very much forward to meeting you face to face soon, somewhere around the world. And in the meantime, I want to thank the INGSA folks for bringing us together, bringing two chief science advisors from across the ocean for this great conversation. Thank you.
Thanks, Mona, and I hope we do meet again soon. And thanks for all your friendship. And next time we'll be meeting face to face and maybe even have a drink.